Welcome back to our channel, that is Ajay Kumar Yadav, and today's class we are going to talk about the relative velocity. So you know what is relative velocity, or you know what is velocity is all about. In this relative velocity concept, we are going to learn about the relation between two different velocities. So first of all, the definition part we are going to learn it there. The definition part is relative velocity of an object 2 with respect to that of an object 1. Definition part we are going to discuss relative velocity. Relative velocity of an object. Relative velocity of an object 2 with respect to the object 1. With respect to object with respect to object 1. So we can also say that when both the bodies are in motion. Second point we can discuss there. When both the bodies are in motion. When both the bodies are in motion. When both the bodies are in motion, so it is the time. It is the time rate of change of position of object 2. Rate of change of position of object 2 with respect to object 1. With respect to that of object 1. So definition part of relative velocity of an object is with respect to object 1. When both the bodies are in motion, it is the time rate of change of position of object 2 with respect to that of an object 1. So let us see the representation for relative velocity. Representation for the relative velocity. Representation for the relative velocity is nothing but representation for the relative velocity. So we can also write the running matters as consider the object 1 and 2 moving along the same direction. Consider the object 1 and 2 moving along the same direction. So we'll consider the object moving along the same direction, that is same direction with a constant velocity. So we can say constant velocity for an object 1 is velocity v1 and v2. So representation for the relative velocity. Consider the object 1 and 2 moving along the same direction with a constant velocity v1 and v2. Okay, so I will consider this is my body and it is moving with the velocity v1. I will consider this is velocity body 2, so it is moving with the velocity 2. So this is the first body, this is the second body. Now I am going to consider that the derivation part of the relative velocity. Suppose the position coordinate of the two objects. Suppose the position coordinate of the two objects. The position coordinates of the two objects are x1 0 and x2 0. x1 0 and x2 0 at the time t equal to 0. At time t is equals to t, at time t is equals to t, the position coordinate will be position coordinate will be nothing but x1t is equals to x10 plus v1t. So x2t is equals to x20 plus v2t. So we can obviously write it as after subtracting. After subtracting, how the equation will behave? That is x2t minus x1t is equals to x20 minus x10. x20 minus x10, and we can also write it as v2 minus v1. v2 minus v1 into t. Okay, since we can rearrange the second term with the second velocity, first term with the first velocity, so we can write x2t minus x20 and minus of x20 minus of x1t minus x10 under the bracket, because it is a first term, which is also said to be as equal to v2 minus v1 into t. So we can write the definition part of it, that is nothing but displacement of object 2 in time t, minus displacement of object 1 in time t is equals to v2 minus v1 into t. We can also write the definition, this term, in the different form, that is relative displacement of object 2 with respect to object 1 in time t is equals to v2 minus v1 into t. Okay, so in some other methodology also we can write that relative displacement of object 2 with respect to object 1, that is divided by time t, which is equals to what we can write, same, v2 minus v1 into t. And the last but not the least, we can also write the velocity as relative velocity of object 2 with respect to object 1. That is nothing but v of 21 is equals to v2 minus v1. We can also write it as relative velocity of object 1 with respect to object 2. So v of 1 2 is equals to v of 1 minus v of 2. So we'll recap the things again to understand more clearly. This is the definition of a relative velocity of an object 2 with respect to object 1. Both are in the motion bodies. So the time of rate of position 2 with respect to an object 1. Then here the velocities of the different objects are given there. Here we can write, for the first object this is the velocity, for the second object this is the velocity. If we start subtracting, I'll guess this term, that is nothing but v2 minus v1 into t. And displacement of an object 2 in time t is, with respect to first object in time t, is v2 minus v1 into t. So relative displacement of object 2 with respect to object 1 in time t is v2 minus v1 into t. So the whole terminology can be written in the word form. Relative velocity, relative displacement of object 2 with respect to object 1 is time t, that is v2 minus v1 into t, difference in the velocities. So relative velocity of object 2 with respect to object 1, v21. Relative velocity of object 1 with respect to object 2, v12. So v1 minus v2. That's all about this topic. Don't forget to comment on this. If you have any queries, you are always welcome for the comment. Don't forget to subscribe and like my channel. Thank you very much. Thanks for the lot.